What's up, everybody? Whoa, whoa, oh. Sorry about that. Didn't mean to drop you, but I'm glad that I did, because that kind of introduced us to what we're looking at today. Ready? Gravity. We're looking at gravity today. You just experienced gravity, right? You fell, you were in my hand, and you fell down. We all experience gravity anytime we go anywhere. We take a step, we get on a bike, we play basketball, we skydive. We're always going to the ground. That's what it seems. It seems like gravity always pulls us to the ground. My kid was riding his bike today, fell, right? Pulled the ground, he was complaining. I'm like, that's what gravity is. Gravity pulls you down, right? Or I guess I shouldn't say down, pulls you to the center. But today we're going to look at gravity and kind of how it works in our solar system. You learned about stars last week, so this week we're learning about gravity, and we'll get into how it affects our planets. But before we get into gravity, I want you to think about the idea of gravity. There was a man by the name of Isaac Newton. Not Fig Newton. Isaac Newton. Well, Isaac Newton had a thought, was the guy who kind of came up with the idea of gravity, and it had to do with something, the apple. Story goes, he's sitting underneath the tree, and apple hits him on top of the head, and he comes up with this idea. Apparently it knocks some sense into him. I know, I'll be here all week. Well, I'll be here till the 31st of May at least, right? All right. So, anyways, going back to our Isaac Newton. Isaac Newton came with this idea of gravity. He came up with 3 laws. And I'm going to go over this very quickly just so you have a background. So, the 3 laws. First law that he came up with was his first law, which is inertia. Inertia is object at rest, stay at rest. Object in motion, stay in motion until acted upon by an outside force. So let's say I take this marker. I put it up there. That marker will stay there forever. It has inertia, right? It won't move unless I shake it or gravity. I pull out. I was the outside force. That's the first one. The second law is the velocity. Objects, so velocity. Objects speed up, slow down, change directions when force is applied. When I say force, it's like right? Force is some sort of push, the pull, right? It changes direction, speeds up, slows down when force is applied. And then, of course, our third law, and this is one of my favorite laws, is every object or every action has an opposite and equal reaction, right? I push back. We push back, I get pushed back. So a ball, perfect example. Bounce the ball pops back up. Equal reaction. I throw the ball down, throws up. You ever see one of those shows where a kid throws a ball at somebody and it bounces back, hits his face? That is kind of the background of the 3 laws. So it was really Isaac Newton who kind of came up with this, and we applied these to what we call outer space, or what we knew is our solar system. So I'm going to erase our board, or I'm going to erase my board, and I will be right back. See you in a couple seconds. And we're back. We were talking about Isaac Newton. Anybody know what season Isaac Newton discovered gravity in? Fall! Yeah. Funny, I know. Yeah. I told that same joke to my dad about, the joke about gravity, and he's still falling for it. I love you, Dad. All right. So, anyways, I know I'm a comic genius, but I'm going to get back to what I'm teaching here. So, I talked about gravity and what gravity truly is. Well, I gave you a definition, but it's really basic. But let's go with a definition that really has to do with kind of the scientific definition. So gravity. Think about what gravity is. So gravity is the force of attraction exerted by a celestial body on an object on or near its surface, right? And we think about the word celestial, a celestial body. When I think about the word celestial body, it makes me think of planets, stars, asteroids, meteorites. Those are all celestial bodies. They are some natural object that is beyond Earth's atmosphere. So, the moon, Jupiter, Saturn, all the planets, the suns, the stars, anything you find in space that's naturally made, not like a satellite, the GPS satellite or the TikTok satellite or whatever satellite's up there. That's what a celestial body is. So the celestial body that actually is in charge, that governs all of the gravity in our solar system is the sun, right? The sun, that's what governs everything. It's in charge of all the gravity. One of the reasons why we orbit it. Now, why do we orbit it? Well, we orbit it because the sun is the largest thing in our solar. It has the biggest mass. And in case, what is mass? Well, mass is how much stuff there is. In this case, the sun is so large that it has the greatest gravitational pull. The bigger the more mass an object has, the more pull it has. So the sun is the largest, so that's what we orbit around. Now, if we go with the Earth, so let's just talk about the Earth. Earth has a much smaller mass than the sun, but then we have something that orbits Earth, and that would be the moon. Now, the moon, right here, is much smaller, has smaller mass than the sun or than the Earth, which means is the Earth here has more gravitational pull than the moon because it has more mass. Now, well, Mr. Pero, how come the moon doesn't orbit the sun? Well, the reason why is the closer an object is, the greater the gravitational pull. So, because the moon is closer to the Earth than it is to the sun, the gravitational pull from the Earth to the moon is much harder than it would be from the moon to the sun. Hence why, we've talked about tides, maybe you've talked about tides, or I know we had a little bit before we left, but the tides is actually controlled by the moon, not the sun, because the moon is closer and it does have its gravitational pull, right? So, yeah, I mean that's kind of a cool little thing, right? So the sun is the largest thing that creates the orbits. Then we have then each planet, most planets have what we call moons or satellites, and those orbit the planets because they're closer. So the closer an object is to another object, the greater the gravitational pull. The farther away, the less gravitational pull. Think about magnets, right? I take two magnets and I get them farther apart. I don't have that pull, but the closer I get them, the stronger it is until they snap together, right? And then you make that most the annoying sounds like stop, right? So yeah, there you go. I got to erase, but I wish I had a giant board. The giant board would be so much easier, but I don't. So I will be right back, and I am going to erase my board, and we'll finish with the rest of the lesson. Cool. See you in a second. And welcome back. Teaching about gravity is just really depressing. It's constantly bringing me down. Right? I told that joke to my dad, like the gravity joke, and he's still falling for it. I'm here all week. Well, technically, I'm here all month because everything's closed. But so let's recap of what we learned today. So, gravity. It's the force exerted by a celestial object or body on another object on or near its surface. So in this case, our solar system, that celestial body is the sun. Our sun is in the middle, of our solar system, and the planets revolve counterclockwise around it. Back in the day, they at one point believed that the Earth was at the center of our solar system and that everything revolved around the Earth. That was known as the geocentric model, but other people believed, and what we know now is that we actually revolve around the sun because the sun has the largest mass, which means has the greatest gravitational pull, which means we orbit around that. And that's known as the heliocentric model. We learned that in the beginning of this space unit. So all of the orbits of all the planets are counterclockwise in what we call an elliptical orbit. And they are moving quickly, and each moves slower because, moves faster because it's got a larger gravity, or the closer an object is, the more gravitational pull it has, the farther away, the less. Think about, right, I think I said this before, the magnets, you put magnets together close, they'll farther apart. But anyways, so remember, the sun is at the center of our universe. It's what governs our solar system and the gravitational pull because it has the largest mass. Then the planets go around an elliptical orbit, and then around the planets are their moons because they're smaller and they're closer. The moons are closer to the planets than they are to the sun, so it rotates there. So that is your lesson today. Kind of short and sweet. I hope that all of you, if you have any questions, let us know. We miss you. I miss you. I wish I was teaching you in front of the class, but I'm not, so we're making do. Make sure you're getting your work done. We love you. I love you. Miss Romero loves you. And remember, Zoom calls on Monday, which is today, or if you're watching this later. And we'll see you Wednesday for the quiz, right? Do your work. Eat your vegetables. Listen to your parents. Have fun. We will see you later. You want to say hello? Hello, my son. Say peace out.
Bye.
No, you gotta say peace out.
Peace out.
No, you gotta not give that peace out. Peace. Now press the button. Ah ha ha.